So welcome to example 4 in our notes for continuity and end behavior. And in example 4, we're going to be examining graphs that have endpoints. So as we look at example A, this is a square root function with its endpoint at 3, -5. And just like before in our earlier examples, we're going to start by going to the left. So as x approaches -infinity, that means we're heading to the left side of the graph. We want to look at where the y is going, and the y is headed up to positive infinity. But now when we go to look at the right side of the graph, right, if we were to say as x approaches positive infinity, we'd never be able to get there because of this endpoint discontinuity, right? Our domain is not over the set of all real numbers. It's a half-bounded domain. So we can't approach positive infinity in the x direction. We can only approach the x coordinate of this endpoint. So as we're headed toward the right end of the graph, we're not approaching infinity, we're approaching 3. But we want to indicate to people which direction we're coming from when we do that. So since we're headed from -infinity towards positive 3, I'm going to put a little negative here in the corner after my value to show people that it's x approaching 3 from the left, right? I'm starting at the left, I'm headed towards the 3, so I'm approaching it from the left side. Okay, then as I'm doing that, I'm getting closer and closer and closer to this endpoint y value at -5, and so the y is approaching -5 as I come at the 3 from the left. Okay, in example B, as I head to this endpoint, as I go to the left, I'm getting closer, closer, closer to -4, but I'm coming from the right side, from positive infinity toward this -4 from the right. So I write my notation as x approaches -4, and then I put a little plus in the corner to show that I'm coming from the right side. Okay, so as x approaches -4 from the right, the y is approaching this positive 3 of the endpoint. Okay, then when I look for the right side of the graph, I can see that as x approaches positive infinity, the y is headed down to -infinity. Okay, so up at the top here, that's what this is summarizing, that when x is approaching an endpoint of a function, the notation needs to indicate the direction that we're coming from to get to that endpoint, right? So if you put a little plus in the corner next to the value, that means that you're approaching from the right. And if you put a little minus in the corner after the value, it means that you're approaching that endpoint from the left. Okay, so that brings us then to the secret question for this lesson. There are 4 problems here that I'd like you to use graphing technology to take a look at the graph. You're going to sketch each of the graphs, just a rough sketch. It doesn't have to be super meticulous, but I want to see, for example, where your asymptotes are, if there are asymptotes in the graph, or where the endpoints are located, if there are endpoints. Okay, so you'll want to indicate a few ordered pairs there. And then once you've got a sketch of the graph to reference, decide if the function is continuous or discontinuous. If it's discontinuous, tell me what type of discontinuity the function has, and then you're going to describe its end behavior using the notation that you learned in this lesson. Okay, when you've answered the secret question, you can upload that page as the last page of your notes to Schoology.